Good morning all. Two packages with near identical things in them. One says conversion board, the other says adapter card. Shall we take a look? Now if there's lots of noise in the background, that's because the ant miners are going flat out, providing nice warmth for me in the workshop because it's a bit chilly today. Right, this one is very well packaged. Oh, that's a nice bag. It's a big connector, lots of connectors, a switch, and an LED voltmeter. Let's take a quick look at the other one. Now I will be turning the ant miners off fairly soon, and I have a fan heater, conventional resistive element fan heater, which I can use while I'm shooting if the ant miners are too noisy for you. Incidentally, these lights are going to get dimmer because I've put a light bulb across the supercapacitor if they're a bit too flickery for you. Let's check this one out. Oh, similar bag. Does that mean it's an identical board? Not quite. It's green. Ah, now that's interesting. This one has the switch, and I didn't really want the switch. It's not a major problem. Oh, it's got far fewer of these connectors. This has only got 12. This has got 8, 6, 17. Well, this is the better unit then. Right, let's turn these ant miners off. So phone comes out of holder. There's one of the ant miners. It's showing 12.1 volts on a very similar looking board. Just press the switch. The LED voltmeter goes out, the ant miner shuts off. Here's the other one here. It's on a similar power supply, but the board is a little bit different. But it has a switch on it, so let's press the switch. And that one shuts off. Oh, it's a lot quieter, isn't it? So yes, these boards are for these things. Hewlett-Packard server power supplies. Now this one is input 100 to 240 volts, output 450 watts, and it has the 460 watts it says there. Oh, that says 460, doesn't it? It's these glasses. 12 volts at 38.3 amps. That's pretty good, and that's what this connector is for. It connects onto this board. Let's do that like so, and then the idea is that this has a sort of felt pad on the bottom, so this will sit flat on your bench. You put mains into here through this got to be careful I don't whack that board now, through this quite clever connector, which, now how does this work? Yes, you can't take the power supply out of the server by pushing that lever if the power connector is still in place, because it would push against it. Intriguing. So that's the 460 watt power supply. I then bought this one, which is a 750 watt power supply. Now these are all second-hand, refurbished. They're all very clean because they come out of server rooms, which are essentially clean rooms. This one has a broken handle, but it doesn't really matter. The same power socket. This one's absolutely lovely and warm because it's just been running that ant miner. Okay, let's have a look at the current spec on this one, if my camera will focus. Oh, where is it? Input 100 to 240, whatever that is, 12 volts at 62.5 amps. There's also a secondary 12 volt supply, 2.5 amps, which must be on some of these connectors here. I've looked at this connector system vaguely, but I can't remember quite how it works. And incidentally, these power supplies have a soft start switch, and the switch on this board, and in this case it's a click on, click off, so the microcontroller must be looking for the momentary action there. On this board, and indeed the board under the bench, it's just a slide switch, and I would prefer a slide switch, so I may not use this one for remote operation, because what I want to do is put well, either a relay or probably a MOSFET across that switch on my wireless remote control system, so that I can turn these things on remotely, because you can leave these power supplies connected to the mains permanently, and then it's a couple of pins on here that you short together. By soft switching this thing on, it provides 12 volts, the Antminer fires up and produces heat. So then I bought the daddy of them all, and this one is the 1200 watt power supply. Let's take a look at this one. Now this one has different ratings depending whether you're using 120 volts or 240 volts, but at 240 volts, input 200 to 240, around 6 amps, output 1200 watts, 12 volts at 100 amps. Yes, 100 amps. This one gets quite warm. It certainly gets a lot warmer than these two, even with the same amount of load. So I don't quite know what's going on there. This one has an interesting, slightly different socket. It's a standard 3-pin IEC, but it's got 4 little connectors up there. I've no idea what they're for. It's got the same, you can't pull this out of the server unless you take the mains out first arrangement, but I just don't know what those 4 connections in the IEC socket are. I tried to look it up and there was nothing online about that particular socket, but yeah, 12 volts, 100 amps. So going back down to the Antminers, this one is an L3 Plus. That runs the script algorithm and primarily does Litecoin. Has 4 hashing boards, but they only have 2 connectors. Now these connectors are just lots and lots of parallel 12 volts. 12 volts on yellow, ground on black. These wires I bought as sets with this board. Oops, don't really want to put USB on there. It's a very similar sort of board, but it doesn't have the LED voltmeter. I quite like the LED voltmeter. Again, there's a soft start switch which shorts some of these connectors together, enables the 12 volts to come out, and the Antminer powers up. So this one actually only needs 8 connections plus the connection for the controller board, so it needs 9 connections. So this board here with its 12 connections would be fine for that. This Antminer is a V9. This runs the SHA-256 algorithm and is primarily for Bitcoin and other SHA-256 coins. So here I've got, well, there are 3 hashing boards and 3 cables per hashing board, so that's 9, plus a cable for the control board. So this one requires 10 cables. I mean, actually that would still work on this 12 connector board. So this one with its 17 connectors, yeah, that's quite excessive, isn't it? This one again, switch controlled, has an LED voltmeter, so again you could put a relay or a MOSFET across that switch and have remote switching on and off of that Antminer as well. And to keep me warm while the Antminers aren't running, yeah, I've got my trusty old Glen fan heater. How's it doing? It's 19 degrees in here, not bad. So let's try these boards out. I'm going to try them on this power supply, which is stone cold because it's the one I'm not using currently. It's not terribly useful for the Antminers because it's quite low power, and so you can only run them at fairly low settings. I've got mains here. This is proper mains from the house. None of your inverter mains from a power pack stuff. Right, so plug that in. There was a little brief flurry of activity from the fan. Curiously, The 750 watt unit, the fan runs at a slow speed continuously, which I quite like for working in the shed, so it keeps the moisture out of it. The others, they don't, but there are little pots just behind this panel, and one of them is probably fan speed relative to power being drawn, so I might be able to adjust them all so that the fan runs at a slow rate all the time. But anyway, that's power, that's mains on there. Let's put the board on. I don't know whether this is going to be on or off when I plug it in terms of the soft switch. Oh gosh, these are really tight when you first put them in. Okay, that appears to be off. Let's switch it on. And we've got 12.4 volts coming out of the power supply. If you switch it off, you can see that fades away. Below about 4 volts, there's not enough power to power the LED voltmeter. We can check whether this is working. No, I believe, yeah, 12 will be on one side of this connector, ground on the other, so I should get it by doing that. That's a 35 watt bulb. Let's just see if that brings the voltage down a little bit, because certainly when the ant miners kick in and their ASICs fire up, it pulls this voltage down, even on this most power, no, this is the least powerful unit, isn't it? So it'll pull it down to 12.1 or 12.0 even. Let's see if this thing does. This is only 35 watts. No, it doesn't trouble the power supply. Still sitting there at 12.4. Good, so that one works. Right, let's try this one. And this one's the one with the momentary action switch. So I'm guessing you press it once to turn it on. So the microcontroller is probably bridging across the 2 pins that are required to actually enable this power supply. You get this red, green, blue flashing light. It doesn't mean anything, it's just pretty. Something else for the microcontroller to do while it's, I don't know, refreshing the LEDs for the voltage. Press again, and yeah, that disables the power supply. Now this won't be as good from the point of view of doing remote control. I actually bought both of these, and I looked at the image they had, and they both had the slide switches. So I would rather have had a slide switch version, because that way I know for sure when I bridge the 2 contacts of the switch that the power is on. Here I can't be sure unless I have some sort of feedback from the 12 volts. But I suppose I could do that. But in any case, I've got the board down under the bench, which also has a slide switch. So I'll probably just not use this one. But certainly they all work. They all provide the ability to boot the power supply up and get our 12 volts at 38 amps or 60 something amps, the orange one, and the teal coloured one, which is the 1200 watts, 100 amps. So shall we just quickly take one of these PSUs apart just to see what's inside? So I'll power it down with the soft switch, remove that, take the mains out, put that somewhere safe, like dangling on the floor. And where's my screwdriver? Let's get a screwdriver to this. So 4 screws on the top, these very tiny short reach screws. These things are incredibly compact inside, so you can understand why they've gone for these very short reach screws. They've had to fit a lot of stuff in a very small space, and this one is the 460 watt. So this one is the least powerful of the 3. You might have a quick look in the big one as well, possibly. Yeah, so those little hooks come out of these little receptacles, and we're in. And under the flap we've got all sorts of interesting stuff. Let's get in closer. So the fan, fairly obviously there, blowing outwards. Lots of inductors, one there, big inductors. I've got a feeling this is an inductor as well. It's a very strange device, never seen anything like it. It's a big sort of, I don't know, there are bits around it. It's got ferrite material. There are wires coming off it which go down onto the board. There's a heatsink with some active devices, some semiconductors there. This is another heatsink with semiconductors. That, I think, is a resistor. Oh no. Oh, 13 ohms, 10 amps, 185 degrees C. It's an SQF10, whatever that is. So maybe that's fusible resistor. We got capacitors or MOVs, possibly an NTC device down there. So really just your expected AC stuff. Oh, there's another wound device there which you can see wires coming out of. There's a monster capacitor down there which I presume is the high voltage DC, so after mains has come in, been rectified, this is the high voltage DC capacitor, would be my guess, and then it's chopped up so that it passes through the various transformers and inductors and can be transformed down to the lower voltage at colossal current. Now around this side there's quite a complex controller board with various chips on. It's highly unlikely I'll recognize any of those. Some of them look proprietary anyway, but there are some pots here, and in fact you can see that there are little windows in this black plastic covering designed to give you access to these very tiny pots. Now the fan connections I believe are here. Yes, I think they run across to this connector which then joins that connector and goes to the fan. It's implemented slightly differently in the different power supplies, but my guess is that one of these pots here would adjust the ratio of fan speed to temperature. That's what I'm guessing, but I don't really want to start twiddling pots without much care. There are 3 pots across there which sit in that window, because I don't want to muck anything up in terms of the 12 volts. I mean, it wouldn't be a disaster to slightly change that 12.4 volts and then put it back, but it could be interesting perhaps on one of the power supplies that I don't use very often, this one being a candidate, to see if I could lift the power, the fan speed, so that it runs continuously and keeps an airflow through the unit so that it doesn't have moisture build up inside. Right, let's just compare the internals then of the big one, the 1200 watt PSU. I seem to remember this being slightly different inside. Certainly you've got that strange mains connector with those 4 gold-plated springs. Can't imagine what they're for, unless there's some sort of compatible mains IEC, it would be socket that plugs into there. Yeah, I just don't know. Well, similar stuff in here. Transformer there possibly, which looks like it's got printed circuit board implemented windings, because there's a circle of copper on a circular board there and some connectors up there. There's the big capacitor, lots of other interestingly there are no sort of conventional toroid wound inductors in here. It's all these things, so maybe they're needed for the higher power. Some very nicely routed cables running around here. Yes, there's much less to see in this one in terms of inductors. They're all these sort of anonymous black blocks. A heatsink there with some active devices on it. Very similar circuit board. Looks like it's a bit smaller, this one. But again, I'm just wondering whether this pot up in the top corner might be for adjusting the fan speed, because once again, this one doesn't have the sort of joined cable halfway down, but the fan connector runs all the way up here to this point, so that could be a fan related pot. Maybe I'll buy one of these power supplies simply to twiddle that pot and see what happens. Of course, I'll have to do that with the mains connected, won't I? There's a little board here with a crystal sitting on it, a little daughter board that goes off somewhere. But this thing is interesting. It's printed circuit board, as I say, with I think these curved windings. You can also see just in there that it's layered 1, 2, 3, at least 4 layers on that thing. So it's a custom built inductor using printed circuit boards as the windings. That's a curious thing. So if you need 12 volts with a lot of amps in a fairly compact space, these things are quite good. And these all come from the crypto mining world. These boards were obviously designed to interface these power supplies to ASIC miners. You can, I don't know how you would tap, yeah, maybe you'd have to get into this. I think these are called Molex Mini Fix or Mini Fit. Actually, I think it's Mini Fix connectors. And I did think when I was looking at those cables, let's have another look at those. These sets of cables here, I think I got 12 cables and that board for something like £6. Well, I've looked these up again on eBay and they're like $39. And you can understand it. I thought, well, why don't I make my own cables up? But even these connectors, these connector sets, they're like 50p each. And then you'd have to buy the pins. Then, of course, you'd have to buy the crimp tool. I don't think you could do it economically, but I got an absolute bargain because I bought 2 of these at about $6 something each. Cheap, but they're not cheap now. That's interesting. I was trying to put this cover back on and the holes don't align. And that's probably because I've put the wrong cover on the wrong power supply. So I wonder if they've done that deliberately so that you can't get that wrong. But yeah, this must be the 1200 watt. Actually, of course, I can look at the fan, can't I, to see that that matches. But yes, on this one, those holes will align. Clever thinking. Now, I've noticed on this one, it says main detection port. So I wonder if that could be used for remote control of this board, sort of as well as or instead of this switch, which is sort of bistable changing state. I'll have to investigate. Trouble is, I can't see the tracks with this bit of foam stuck on there. But I suppose I could bleep it through or measure voltages or something. Might be worth looking at that for my remote controlled switching. Now, if you want to get one of these power supplies to get lots of 12 volts or 12 volts at lots of amps, you might find this board perhaps easier for just tapping the 12 volts off. You also get the switch, which you can enable the soft on and off on this thing. There's also a resistor and a green LED to show when you've got 12 volts. Now, I've started pulling the connectors off this board because I wanted to get a third power supply running a third ant miner, but I don't have any more of those cables that I showed earlier. And the power supply that I got with my first ant miner suddenly stopped working, and I'm not entirely sure why. In fact, I think I'll go and get it. Yes, this great big thing, which I was using and it was working fine, but what it does now is it trips the RCDs in the workshop here, and if I plug it into one of the power packs with an inverter, it comes up with an error message, over power. So I've got a funny feeling that this one has an effective short across the mains, and I'm just thinking it could be the MOV. But my plan for this is to cut all these cables off the PCB inside there, wire them straight into the holes that I've made on this board, and that way I would have the ability to run a third ant miner. Incidentally, a word of caution, this board does not go like that, it goes like that, so the power supply sits upside down. I just connected it like that on that big 1200 watt power supply, and guess what? well, it seems to have survived. So I'll put links to these two boards in the description below. If I can find a link for this board, possibly with or without the cable sets, really just so you can see how expensive it is, I'll put a link to that. I might even put links to those HP PSUs, but they all came from UK sellers, so that will only be relevant to UK viewers. But those are my Antminer. Well, really they're just LED voltmeters, aren't they, and a board which distributes a lot of 12 volts. Cheerio.